Hey there, everybody, welcome back. We're gonna be doing 2.3 and as much as 2.4 as we can get done today. 2.4 can be long, it has that quotient rule that I was just talking about. And most students find it difficult to remember how it goes the first time. But before we get there, we had one more theorem in 2.2 we wanted to cover. Maybe I'll make this a separate little video. This is where I'm at 65. Finishing out 2.2, I'll say part B. We had one more theorem. And the theorem goes like this: if f has a derivative at x equals c, then f is continuous. At x equals c. And this is a notation. F here is f of x. You start getting lazy and they're like, at some point, you're just gonna be willing to accept f means f of x. So we'll do a little proof of it. Given that the derivative exists at c, i.e. f prime of c exists, we need to show that the limit as x approaches c of f of x equals f of c. Or equivalently, the limit as h goes to 0 of f of c plus h equals f of c. I get diving straight into it and going back to it. Get to the stuff that's like, let's make it useful first and then go to why it works. I can get why someone, why it can talk like that. So,
I was gonna say no, but kind of self-taught.
oh,
Yeah, from old book and Khan Academy, just self-taught.
so, assuming h does not equal 0, then we have f of c plus h. This is gonna look funny, but what I'm gonna do is I'm gonna add in f of c and subtract f of c. So these two together cancel. But by introducing them, I can start manipulating some shit. Now I'm gonna take these two and put them together and multiply them by h over h. I can do that because h doesn't equal 0, so h divided by h equals 1. And so f of c plus h equals f of c plus f of c plus h minus f of c over h times h. where I just took the denominator and put it with the bracket. Now we're gonna hit this whole bad boy. Maybe I should do it like this, put it on both sides. And I didn't give myself room right there. We're gonna do limit as h goes to 0 on both of them. So I'm just gonna write it fresh down here. Limit as h goes to 0 of fc plus h equals limit as h goes to 0 of fc plus the limit as h goes to 0 of f of c plus h minus f of c over h. And we're gonna do limit as, since we can do a product, we can separate it like that. Where I just went and took limit and applied it to everything inside.
Multiplied by the h on the end.
Yes.
Okay.
It's not multiplied by, yeah, it's getting it here, but that's where this one's coming. So
Okay.
that one's that. That's that, and that one's directly there. So limit as h goes to 0 of f of c plus h. There's no h in this one, so doing the limit doesn't do anything good. That is f prime of c. And it's multiplied by the limit as h goes to 0, it's multiplied by 0. So we can see the multiplying by 0 cancels it out. We have limit as h prime of 0 of f of c plus h equals f of c. And we proved what we needed to prove.
Where did the prime one come from?
What did what?
The f of prime.
That's this. If we had used x here instead of c, it would have said f prime of x. That's the different definition. That one. So end result, if f is differentiable, it's continuous. At a point. It's continuous there. The reverse is not necessarily true. Continuity at a point. Does not mean differentiable.
Can it be discontinuous at a point and still differential? or is that,
Say that again?
can it be discontinuous or, let's say we're working with a graph, at a line, can it be still discontinuous at a point, but still differential?
I want to say no, but I'm trying to think if there's an example of that's contrary to that. No, if it's discontinuous there, it can't be differentiable. Cause differentiability, you know, like this thing implies continuity. You can't have differentiability if it's not continuous there, cause this limit is gonna break. What we just did isn't gonna work. It can be continuous at a point, but not differentiable there. And we just did an example of this. At the end of our last lesson, remember we did f of x equals the absolute value of x? The graph of that is a v. And at x equals 0. The function is continuous. But f prime of x does not exist at 0. Because when we did it last time, we showed that the limit. As x goes to 0 from the left is not of f of x. Plus h minus f of x over h. Does not equal the limit as x goes to 0 from the right. We did that at the end of the last week. One of them, because the slope here is -1, the slope here is +1, so -1 does not equal +1. This was -1 and this was +1. All right, we're mostly done with the limit stuff. There will be a couple times where it pops back up. Only when it helps us to do derivatives that we're not gonna learn, like the formulas for. Starting right now. Hit stop record and make a new recording.